I've got this Bosch professional grinder or die grinder. It's variable speed and it goes up to 30,000 RPM, and it's got adaptive electronics in it so that if you put a load on the spindle it doesn't slow down, unlike many grinders. So that's quite nice. So I was thinking I might be able to fix this onto the saddle of my Harrison M300 lathe and turn it into a kind of tool post grinder. This thing here is a rubber sleeve which comes off, but then annoyingly this is on a taper. That's about 34 millimeters and that is 33 millimeters. So we've got a 1 millimeter taper over this distance. So I was thinking I could bore a 33 millimeter hole through a lump of metal and then bore it on a taper so that it would fit this exactly. I bought two 80 millimeter diameter by 40 millimeter thick steel billets from eBay. No idea what kind of steel they are. I put them in the four-jaw, but I haven't clocked it in because I'm just going to face them off to square up the bandsaw cut. The tool is a smidgen low, but of more interest is the ripple effect as one gets towards the centre. I don't know whether this is because the cutting speed is going down as one gets towards the centre, or whether it's an indication that the cross-slide gib is not as tight as it should be, or is generally the ways are a bit rough in that area. I'm not sure. I was intending to mill the two faces of these billets flat, but I discovered they wouldn't fit in my vise on the mill, so I decided to mill off a small amount from each side of the circle so that it would fit in the vise. I'm just shaving a bit off the circumference of this thing. Because it won't fit in the vise. This is the annoying thing about this mill, that one can't hit the workpiece with a hammer because there's all this stuff in the way. My theory is that this would now fit in this vise this way round. Yes. Right. I've got to just deburr this.
Alright.
So I did that on both sides and then measured the parallelism of it.
So that's 39.870, 0.837, 0.863, 0.821. So we take 0.870, 0.821 minus 0.049 millimeters. Was that 49 microns difference? Which is what? 1.9 thou?
Could do better. So having flattened the face of these discs, I put one of them in the vise and drilled 4 6mm holes suitable for M6 cap head bolts. And I drilled a 30mm hole for the tool post mounting bolt.
Right, well I think that's all I need to do in this position. What we've done so far is put 4 holes in and draw a couple of lines, or 5 holes actually, and draw a couple of lines. That's going to have to do for this evening. So I've got this and I've transfer punched these 5 holes through to there, and now I'm going to drill and tap that M6. I must get a spiral point tap or some kind of machine tap to do this instead of this somewhat manual process. In any case, this tap isn't deep enough to go all the way down to the bottom, and I want it to go right the way through. It won't go further than there. Right. the sharpest drill I've got. Right, so at last my screws have come. So will this screw together? I'll put it on right, so that's fixed those two together temporarily. I wonder whether to put some Loctite in between them, because the next thing I want to do is to bore a hole through here, right the way through. But before I do that, I'm going to just skim these with a shell mill, because they're not exactly the same size. Right, so I've Loctited this together. Unfortunately, it won't fit in my vise this way or that way. So I'm going to try and use another vise which I've got, which I haven't used before, which is this one. If I can clamp it on here somehow. Well, I hope this is going to be alright. It's a bit Keith Robinson, the whole thing. Well, I mounted this in the vise so that the centre line here is just below the split, and I think it is all at the right angle. Well, I'm drilling this hole very slightly above this line, and that line is such that if I put this thing on here, that line would be on the centre line of the chuck, of the spindle. So anything I put in this hole will be very slightly above centre line, and I can then mill something off the bottom of this if necessary to bring it back onto centre line. See if we can drill this through here. 7.5 millimeters, and I've put the speed down to 370. See if we can get any joy with this. Whether the thing is blunt or not, I don't know. Right, this is 20 millimeters and 125 RPM. I think the clanking noise is caused by the join in the metal. The end of the flutes on the drill, so you've got to be very careful now not to get up. But we should also be nearly through. Right, so that's 20. I can use the boring bar now. Well, this is the biggest boring bar that I had for the Chinese mini lathe, and it is a solid carbide one, but it's the only one I can practically use until I get a bigger one. This is 1200 RPM. Alright, I'll engage it properly. This is 1200 RPM. Too fast. Just 800. Something is vibrating because this is an off. So the problem is that this piece of packing is sticking out beyond the edge of the tool holder, and therefore hitting the work before I got to the point where I calculated I should stop. So the problem is that the workpiece is slightly unbalanced, and so is the chuck, in the sense that some jaws are further out than others. Right, well, I put a carriage stop in so that I know exactly how far I can go. And there was a problem with the workpiece hitting this springy thing. Didn't do it any harm, but I've just stuck the tool out a couple of millimeters more. Right, this is 1 millimeter depth of cut at 800 RPM. There's horrible chatter in there. This is close to the final bore, and I'm taking a slightly shallower cut, and possibly with a slower feed rate, and I lost the sound on this clip. Well, now I'm just checking that the grinder will just fit into that hole at its narrowest end, and the microphone is still off. Right, well, the angle is 0.95 degrees, which means that it's got to go in by 1.12 millimeters over a distance of 67.2 millimeters. So I've measured 67.2 along here, set this to 0, so if I move this along from this point to that point, it should go up, it should go down by 1.72 millimeters, so that's 1 millimeter, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7 are on the mark there. That is 1.74. A micron, a smidgen over. It will have to do. Right, so we're going to bore at an angle using the top slide, and this is 540 RPM at the moment.
Trouble is I can't move this thing at a regular speed, so I'm just taking very light cuts. I wonder where we are, in fact. $35. This is more than I wanted, so maybe that's enough. Let's see. Where's the test piece? Well, I've actually overdone it slightly. This should go right through. I wonder why it's not going right through. Oh, well, for a start, we've got a whole load of stuff in there. It does. Not really sure where we are. 5:40. I've lost track of where I am now. I think I need to go right to the end with this. Need to clean it up a little bit, don't we? This is slow work. That seemed to be all right, except I needed to bore out the first centimetre of the hole to take account of this larger diameter. We'll do this untapered.
Let's see how that does. Right, well, I think that's going to do. But I'm a bit worried that it's actually only binding on that and maybe not down on here. And I can't really see. Well, can't really see without taking it out of the chuck. And once I take it out of the chuck, that's game over. We'll never get it back here, will we? Well, a little bit of deburring required. I fear this is not going to be perfect. Well, actually, it may not be bad. Well, we seem to have made a fair amount of mess. I'm not counting all the swarf that ended up on the floor or in my rubber shoes. The soles of my rubber shoes, I have to pick them out with pliers when I get into the house. There must be a better way. Of course, I would like to make bigger chips than this, but sometimes you just have to take very light cuts depending on what you're doing. Haven't really, got my head around feeds and speeds and what this lathe can do yet. So, what I'm going to do now is to undo these 4 bolts and put the blow lamp on it to release the Loctite and get back to 2 halves. Right, well, I'm cooking that part in my oven at 250 degrees C, which is the highest temperature the oven will go to, and also happens to be the temperature that Henkel recommend for separating Loctite parts. Right, well, it's been in there for a reasonable time. I'm hoping it will just come apart on my hands. If not, I'm going to take it into the garage. Yes, it did. Good. I decided to put it in the oven rather than use my propane blow lamp because if I'd used the blow lamp it would have discoloured the metal and I'd then have to clean it up again, whereas this way it came apart with no trouble and I've just used a little solvent to get rid of the remaining Loctite. Well, they don't look too bad. However, I've just realised the mistake that I've made. If we fit the thing firmly in there, we can see that in fact it is only gripping at each end, and the taper is at the wrong angle. I'm only saved by the fact that this lip here is bigger so that I can still grip that. Did you spot my deliberate mistake when I told you what the angle was here? I'd measured the 2 diameters and therefore I should have halved the angle there. Both sides of a cylindrical object are tapered. So I've set the taper at twice the angle it should have been. However, I think it'll still be all right because we're still gripping it at both ends. And maybe I never needed to grip the whole thing anyway. Just gripping it twice is good enough. But next time I won't make that mistake.